Here are some of the examples available to our membership. The Safety, Health, and Field. Members are able to download and customize their own safety and health manual. Also, we have Silica resources and many more. All these resources can be found on our website, www.swrionline.org. Under the tab, you're going to find labeled resources. If safety is one of your company's core values,
What am I clicking
and you want
on?
to get involved, you can join us in the next safety committee meeting on Monday, June 12th at 2 p.m. Central Time, 3 p.m. Eastern. Our safety committee is always looking for new members, so please email Nicole Day up if you would like to participate. Now I have the honor to introduce two of the best safety professionals in our industry, Mike Wiley and Jim Doherty.
Shut the fuck up for industry.
Yeah, that's right. So Mike is with Tightly Grown and has more than 17 years of experience in occupational safety and health management and access solutions. He has an extensive training in occupational health, safety, and health management. He's a level 3 SPRAT certified technician. Mike also provides training for SPRAT L1, L2, and L3 technicians. Committed to providing a safe and healthful workplace. Some of Mike's areas of responsibility includes compliance with all state and federal regulations relating to occupational safety and health, providing safe and equitable access to difficult to access work areas, providing road access program, administration, leadership, training, information, resources, and policy development. Jim is with Industrial Access and Safety Specialist of Spider, a division of SafeWorks. Spider is the premier provider of power, scaffold, and platform solutions for construction and industrial access applications. Jim has 37 years of experience in construction, project, and safety management, primarily in bridge, power generation, and custom high-rise building access applications. Jim has been a firefighter for the past 40 years. His training and hands-on experience have helped him develop workable, customized rescue solutions for both high-angle and confined space rescue. To start the presentation, please help me welcome Mike Wiley.
All right, before we get started, if I can have everyone place themselves on mute. I know there was a few of you guys who got on late, so just a quick recap. If you guys have any questions, hold them till the end. You can go ahead and submit them in the chat box, and then we'll get to those after the presentations. All right, I can still hear some background noise, so if everyone can go ahead and place themselves on mute. All right. Gonna share this in one moment, and then let me go ahead and find Mike Wiley on here because I think I may have muted him. All right. Okay, I'm gonna start the video. Did I stop the video?
You did.
Hold on, guys. I'm so sorry. Now. What is that? So sorry, guys. Hold on.
Okay, Nicole, is it over to me now?
No, actually, I accidentally stopped the video. Hold on. I'm so sorry. And I'm not sure where I stopped it at. Can everyone see that?
No, we don't see the video yet.
Everyone see that?
Yes.
Okay, my apologies, guys. Okay. All right, Mike. Now it's your turn to speak.
So good morning. So we talk about rescue all the time, and that's kind of a big, you know, a big moment when you have to perform one. And I don't think anyone here wants to have to do that anywhere. But planning for it's important. Making sure that we have the right equipment, that we're selecting the right tools for our employees, and that they have the proper training in case they do have to be rescued. Because it's not all about the rescue, right? It's also about the rescuee. How you're set up can make that rescue very simple for someone that can perform, or it can make it very complex. You can also create situations where you put yourself in danger by having lanyards that are too long, exposing yourself to traumatic fall injuries, or knocking yourself out by falling out of a swing stage and falling an additional 6 feet where you're underneath the gear. And all of these things can happen that would create a more difficult situation for a rescuer to attend to. To prevent that, we have lots of different ways, right? Shortening our lanyards. So ANSI standard for a lanyard is 36 inches. Now that lanyard on a rope grab, why they say 36 inches is because our maximum free fall distance that we can ever be exposed to is 6 feet. So if that rope grab ever travels below your back D-ring, we have to have it short enough that if you were to fall, you don't extend past the 6 feet of free fall. But we can actually go shorter now, right? The shorter we go with that lanyard, the better off we are. And as long as you have the proper equipment and tools in your swings while you're working, that lanyard really doesn't need to be any more than 18 inches. Other things that we can do is things like rig to rescue. So rig to rescue is kind of a huge deal. There's two different components about that. Jim's going to really talk about the second component too. I'm going to talk about the fall arrest component. Rigging to rescue means that we're rigging with equipment that is designed to be used in a rescue situation. So rigging with 13 millimeter, 11 millimeter ropes, using fall arrest devices that are compatible with those systems. And then on the top side, on the top of our building, really rigging those systems with descenders or devices that will allow you to lower a victim out. So if a victim does fall, nobody has to go get them. You just walk up to the roof and lower them out. So I have an example of what that looks like, and you guys can kind of see what that rigging looks like from two different manufacturers. Nicole, can you get me a screen share?
Oh, yep. I'm sorry. I thought I set you as co-host so you could do that. 1 second. There you go.
Mike still there?
Yeah, I'm here.
Yeah.
You guys see that? Okay.
We just
See
see your
desktop.
desktop. There we go.
So this is what they're using here is an IDL. On the top side, you have basically, let me get back to this so you can just kind of see what this looks like. So you have an IDL, well, it uses 13 millimeter rope. And then on the top side here, they have basically a carabiner and then a roller over the edge of the building. So when that victim fell, they can basically walk up to the top of the roof, grab this device, and start lowering that victim down to the ground without ever going over the edge. So that's an example of the IDL system. Another system that's out there that's very popular is a CMC system, which is this guy right here. It's same kind of device. You have a device to basically raise a victim, and then a device to lower the victim out on an ASAP. So this victim set up with an ASAP, and they're basically using a CMC to lower that victim to the ground. Couple other things that I like to talk about when we talk rescue is ensuring that your workers don't have a bunch of extra equipment with them, extra tools, extra this, you know, all these extras hanging from their harness that they don't need, and all the extras hanging from the swing stage that they don't need. The more of that stuff that's involved, the more complex things become. If I'm coming down to a victim and he has a bunch of roto hammers and tools all tied off to him that have cords connected to the stage, it becomes more work to get that victim down. And every minute that we're spending working with that victim to get them off the line is another minute that victim's having changes to their blood types. You know, their blood is becoming poison in their body, and they are becoming more in a critical situation the longer they're out there. So we really want to focus on bringing those tools and those things that we only what we need and nothing more. Paying attention to our rope grabs and our lanyards, keeping those fall distances very, very short if we can. And then really just focusing on equipment selection. Make sure that you guys are purchasing equipment that is compliant, that can be utilized. And then if you're in a situation where you don't have windows or decks or things like that, try to think about rescue and how that's going to happen. Who's coming to get you? Where are they? How long is it going to take for them to get there? And is this a situation where I need to rig to lower so that I can lower these guys out and get them out of a situation if they ever get into it? And with that, I'm going to turn it over to Mr. Dotery from Spider.
All right, let me share my screen. All right, Nicole, am I sharing properly?
Yep, looks good.
I'm just going to expand upon what Mike was talking about on rigging for rescue. A lot of companies are currently supplying rope access technicians to do some of their inspections and work, and may have the workers trained properly to actually come over the wall and go actually do a pickup type rescue. The majority of the companies I deal with really don't have that. They really basically are set up with ropes and rope grabs and anchors tied to 4,000 or 5,000 pound structures on the rooftop. So we're going to talk more about what you can do and how you can rig to make it easier while you're waiting for the fire department to come or rescue to come, to keep your people comfortable and also to actually get them to the location. It's safer for them actually to hang. So the pictures you see right here, you have a guy who's hanging from a swing stage on the left-hand side. Let me set my clicker real quick. I'm sorry. All right. The gentleman here is in an area where the swing failed and he's close to a window, but he can't get himself up to the window and he can't get anywhere lower because he's actually tied off onto a lifeline that has a hard stop on the top of the rope. These two guys as well are tied off onto areas where there's a hard stop at the top of the rope, which sort of limits their ability to travel up or down. It stopped them from hitting the ground like it's supposed to, and the lanyard deployed and gave them the shock absorbent qualities against their body. But they're in scenarios where if somebody on the job site could find a way to get them down 6 foot, they could go in a window, or up 6 foot, they get in a window or onto a balcony, whatever it may be. So when you're rigging, this scenario here as well, you have two workers hanging from lifelines. It appears that someone on the ground is trying to pull on the lifeline to bring this gentleman over to the balcony. The problem you're going to have, even when he gets over there, for him to actually detach and get off on that balcony safely to eliminate any kind of suspension trauma is going to be difficult unless you plan for it ahead of time. The top of the rope, when you guys go to normally, you'll come over the wall, you'll anchor off onto an anchor point on the rooftop or tie back anchor on the rooftop, and they'll normally tie a knot. And if it's a 150-foot drop, they'll bring a 170-foot piece of rope. They'll tie a knot off right here and drop the other 150 down to the ground. But that limits the ability to lower anybody because you only have another 20 foot of rope on the rooftop. And in the scenario on the right here, you pretty much put the exact amount of rope out, exact amount of rope down, the guy's hanging from it, but that's your hard stop and it sort of limits your rescue ability. And this basically just gives you the scenario of the things that people are using to tie off onto rooftops. And usually if you can't tie a knot, you tie a lot. And this knot here, I'm not exactly sure what that knot is, but that's what the gentleman's hanging from if by chance he became suspended. So what we're looking to do is introduce a few other parts and pieces into the rigging scenario. This is a lowering device called a Petzl ID. Basically what it is, instead of having a knot up on the rooftop, the wire, your lifeline would pass through this braking device. And then you'd have an additional 150 or 200 foot of rope in a bag next to it that you could actually use to lower a person down to the ground in a scenario where they get hung from their lifeline. So in a perfect scenario, in a typical world like you guys are doing right now, your rope would be going from the ground up over the edge, tied back into an anchor point with a hard stop. If you add a few different parts and pieces to it, you now have your anchor points going around structural steel or a structural column or whatever you can find on the rooftop that's going to give you a 5,000 pound anchor point. It goes into a plate right here that allows you multiple rigging points. Carabiner goes to what we're calling a lowering device or a Petzl ID. And then the remainder of the rope comes back into a knot that we tie for a rescue knot or a safety knot. And what that acts as, if for some reason this device is installed improperly or fails or doesn't work properly, it would basically just allow the rope to travel through until this knot became engaged. And now you'd be hanging from what you would have been hanging from before and in no worse off a situation than if this didn't exist at all. But ultimately what this knot gives you is a backup. So the rope comes out of the terminate or the lowering device, goes into the knot, and then the remainder of your rope is inside of a bag up on the rooftop nearby. So if for some reason or another something happened, you now had the ability to have rope that would get your person down to the ground, get them onto a balcony, get them to a lower elevation. And this is all rigged ahead of time. So in order to set this into process, it's not a difficult situation. Once again, here's your bag, here's your knot, and here's your lowering device. The wire or the lifeline travels across the roof, goes over the edge, which a lot of times you put rubber hose on or whatever you can to protect it so it doesn't dig into the edge or dig into the rope. We actually use what's called an edge roller, so that if you have to lower, it's lowering over sheaves that are actually smooth, that allow it to ride over the edge without digging into the metal right here and possibly cutting through your rope. And also in a raised scenario, it eliminates the friction you would have at the point of contact on the edge of your parapet wall. The additional line right here is just a tie back so that nothing happens to this and this doesn't come loose and come down and find you on the swing stage or when you're hanging from your lifeline. Rope grab is similar to the rope grabs you're using today, but it's designed for a Kern Mantle rope or a rescue rope. And this is the type of rope you would be using as opposed to using like a 3-braid rope like you normally use in today's world. So right now we have our worker suspended from his harness, fell out of whatever he was hanging on, swing stage, fell off a balcony, and now he's hanging from his lifeline. Rope's going over the edge here, so you don't have any damage done to the rope or damage done to the edge or any kind of a chance of cutting your rope as he's hanging. And he's hanging directly below the lifeline, which is either a lowering point or a raising point. Once this happens in this scenario here, your workers will normally call 911 to get rescue services on the way. But in most cases, using this system, they'll be on the ground or on a safe location before the fire department or rescue services get on scene or even get out of their building. It shouldn't take very long at all. Depending on what the site-specific safety plan is and what the site-specific notification plan is, once you have a situation like this, that would get put into play. You'll establish communication with the worker that's hanging. You'll assign someone to be either the spotter up at the edge on the rooftop, tied off onto a lifeline and tied to an anchor point, or on the ground or lower elevation so they keep constant contact with the worker so he knows what's going on at all times. You'll develop a rescue plan or an initiation plan, and you'll let the worker know exactly what's happening during that plan. So when that rope starts moving, he doesn't think someone untied his knot and he's following down, but it'll allow him to be lowered to the ground. Next step you go up to the rooftop where your anchor point has already been established and already been set up. Untie your knot, because as you play rope out through this device, it needs to get the rope from the bag through the device and lower to the ground. So this knot, which was your backup safety, now becomes a part of your plan to actually play the rope down. Run the rope back through a carabiner. This is the rope that's going to the bag. This is the rope that's going to the person. There's a handle on this device that actually will operate the handle into a device, and there's a sweet spot that's about maybe 1.5 centimeters wide. When you get into that sweet spot, it will now allow the rope to play through this device and lower that rope. Your other hand is going to be holding on to the rope that goes back to the bag and applying tension to it so you can control the speed of the travel of the worker as he's hanging down to the ground. At that point, you can lower them all the way to the ground if need be. If you're on a 20-story building and you can get them to a lower balcony or a window as you're coming down, you can lower them and stop them there as well. So it gives you the option of taking them all the way to the ground because you have enough rope in the bag up top, but it also allows you just to get them down 6 foot to get them in a window or down to a balcony, whatever it might be, to be able to get them safe and get them in the building. You'll notice we actually installed suspension trauma straps on the dummy just as an example, but when you're hanging in a harness, you have about 15 minutes worth of time before the ill effects of hanging that harness actually start to affect your body, because the blood from your legs can't get past the straps and can't get up to your heart. After about 15 minutes of hanging in a harness, your body's going to probably pass out, and you're just going to be hanging there as the body protects its brain and protects the heart with the blood flow and stops flowing blood out to your extremities. So while you're hanging, or while the person is hanging, if they have suspension trauma straps, or if they have the knowledge of how to just tie a knot in the rope they're hanging from and stand up in that knot, They can be up in the air indefinitely while you're going through a rescue or waiting for rescue. But these straps actually work out real well. And they're simple to use. There's about 5 different manufacturers out there that make them. I know most of the contractors I work with in my area and in the industrial world supply these to their workers so that if there is a situation where they're hanging, they can actually deploy these straps and take the ill effects of suspension trauma away from their person. So at this point, we have the ability to lower this man down to the window and get him in and get him to safety, lower him down to the rescue ladder from the fire department and get him down to safety. And majority of times, once you get up there and establish your plan and establish your communication plan, you should be able to have him on the ground after the person gets up to the Petzl ID and you actually communicate with your worker. I would think you'd have him in that window in about 3 minutes. It could be 15 minutes to get him down to the ground, depending on how tall the building is. But just getting him moving in the right direction or getting him moving to an area where you can pull him in a window and pull him in safely, which would eliminate the 15-minute suspension trauma issue if by chance he didn't have any kind of leg straps or any kind of suspension trauma straps. This is the device right here. Here's the handle we're talking about rotating around. This little notch right here, when it's in this area, basically gives you the ability to lower the rope. The benefit of this also is that it has safety built into it in the fact that if for some reason the person lowering the rope lets go of the handle, it automatically snaps back to lock. So you have to keep this device in the right spot, in that sweet spot, so it'll actually play out rope. So if the gentleman on the rooftop or whoever's operating the device panics and lets go, it's going to stop. If he actually takes the handle and pushes it too far forward, it's going to stop. Or for some chance that person would have a heart attack or have a medical emergency while he's lowering somebody, it's going to automatically lock up and keep the person that's hanging from the lifeline safe at that time. So the safeties that are built in actually work very well and into your advantage. The next scenario we have is gentleman fell off the swing stage fell. He's about 6 foot below the window. The guys here must not have enough oomph to actually lift him up and get him in the window. So he's not in a really nice position right here. So this device also allows you to raise a worker if you have to. You can raise him 30 stories if you wanted to, but you're probably going to raise 6, 8, 10 foot, whatever it may be, to get them to a safe location and make it so that they can actually make themselves safe. So once again, you go back up to the rooftop. Everything's set up the way it was when we left before, whether it was a raise or lower operation. What you're going to do at this point, this device actually acts as a sheave and it has progress capture in it. What that basically means is as you pull rope through it, it's going to lock itself off and not allow that rope to travel back through unless you open up the handle. So you create a 3-to-1 pulley system, which is basically known as a Z-rig. Very simple system. You're going to put a rope grab device or a Beckett device on the rope. You're going to put a sheave right here. And as you pull on this piece of rope, 100 pounds worth of pressure is going to give you 300 pounds worth of pull for lifting up. So most people can actually pull enough to lift another person. If not, you could put 2 or 3 people on here, no problem, and raise that worker up to a point where they can actually travel in and get through a window. So you have the same devices you already had set up. All you're adding are 2 parts and pieces to this to make this a raising system. So the devices we're talking about are very simple. They're not that expensive to put together. They're probably not what you already have in your inventory, but you're going to change out your rope to a different type of rope grab. And that rope grab comes with a different type of a shock absorbent lanyard on it. This box over here basically shows you what you have for raising and lowering with the device. And then this is basically your wall roller right here. So it's not a huge amount of equipment to switch over to this. There will be some expense involved in it on the front end, but it will allow you to make sure that your workers can get up or get down if they ever get suspended from their lifeline without any kind of a long duration timeline that's going to cause ill effects to their bodies. Next section I want to cover is basically things that you can do to eliminate the possibility or to limit the possibility of having to hang from your lifeline. Wire rope is probably one of the bigger issues we see when it comes to anything that requires a rescue. Power is the biggest problem we see when it comes to just simple issues on job sites is lack of power, bad power, and not being able to have proper power. But power does not usually cause you to hang from your lifeline. Normally it's your rigging fails or your wire rope fails. And the wire rope doesn't normally fail on its own. It usually fails because of lack of inspection or lack of understanding on how the wire rope works and how it goes through the motor. Wire ropes you use on suspended scaffold are normally 6x19, 5x26, whatever that different strength that you guys are using, depending on which manufacturer you have. But basically a 6x19 wire rope is you have 19 little wires wrapped into 6 strands wrapped around the center core. This wire rope's good for about 11,500 pounds. Your motor is a 1,000-pound capacity motor that's supposed to stall at no greater than 3 times its rated load. So your motor should never be able to pull hard enough to break your wire rope. And wire ropes don't normally break on their own. They usually break because of reasons which I'll go into in a couple of minutes. Any kind of obvious damage you find on your wire ropes, depending on where you're operating, this could be a wire rope that was used before, run over by a forklift, or somebody dropped a brick, whatever it may be. Trying to pass things like this through your motor are going to cause you nothing but problems and nothing but headaches. Easiest way to find a broken wire on a wire rope is in the down direction. Have a rag and a gloved hand, and as you're coming down, just let it slide down that wire rope. It'll actually grab that piece of rag out of your hand and pull it up in the air as it passes by a broken strand or a broken wire, which will show you where it's at. It may be on the back side of the rope that you wouldn't be able to see when you were actually traveling. But broken wires are the biggest problem you'll find. It's not very common to have broken wires, but during most accident investigations, it comes down to the fact that the wire was busted in one spot. And then as the pictures I show you farther down, it'll actually explain in more detail. As the wire rope comes into the motors, it comes in, wraps around a sheave one time, and comes back out the motor. And this loop is what you're traveling up and down on inside of the motor. These wheels right here are under extreme pressure, and they push that wire rope into a V groove in the sheave that actually gives you tension, which allows you now to climb up and down that rope. Where the problem comes with a broken wire is as that wire is traveling around here in this tight area, if it were to come loose, you start seeing things like this. When we get motors back in off rent from people that are damaged and a wire rope has been cut off in the motor or cut off below the motor, or even post-accident investigation, we'll find this going on inside the wire rope or inside the motor. Wire rope comes in, wraps around the sheave, somehow or another gets hung up inside the motor, and then the operator starts going with the up handle and down handle, or pushing the buttons up, pushing it down, trying to free himself up. And while they're doing that, they're building up wire rope inside the motor and busting castings and busting parts and pieces inside the motor, which ultimately would be what normally shears off the wire rope and causes you a problem. So you start seeing things like this where this wire is almost cut all the way through inside of this motor. This wasn't an accident. This is a motor that came back into our shop for service, but this was as close to getting to be an accident as you can actually see. So by not inspecting your wire ropes and not really doing good due diligence on making sure you don't have any damage to that wire rope is where you start coming into scenarios where you may end up needing 911 services to come rescue or be able to lower yourself down to the ground. This is another one here where the wire rope inside the motor gets hung up behind that wheel that keeps it into the pressure with a broken strand, and it starts breaking other parts and pieces inside the motor, which once again could cause that motor to come loose from the stage, or could cause a way that this wire rope can actually get shear off inside the motor. So if you pay attention to your wire rope and you keep it so that you're not going to have any damage to it, it's not going to have any big kinks or any big milk marks on it, it should lessen the chances of you ever having to hang from your lifeline. When the wire rope comes into the motor, it passes through an overspeed device. This device has a wheel right here that actually rubs up along the wire rope. And as you travel up and travel down, this wheel spins at a normal speed. If for some reason that wire rope were to break and it breaks below in your sheave right here, this device is going to spin. This little piece is going to come up here, trip this button and cause this device to lock up. And it's going to actually have a set of jaws inside there and grabs that wire rope. And that's going to stop this wire rope from pushing out of the top of the motor and having you hang from a swing that's no longer horizontal, it's in a vertical condition. These are things you need to inspect prior to every shift to make sure that if something happens to your wire rope inside your motor, that you've inspected that and make sure that's going to work. And that's a part of your daily inspection. But if you've done that and this wire rope is operating properly, this wire rope should never be able to break inside this motor and push out of the top of the motor. It should never leave you in a vertical situation. Next quick point I wanted to get onto is basically welding from suspended scaffolds. I know I'm talking to a primarily waterproofing masonry contractors that would tell me that they don't normally weld off their suspended scaffolds, and that's all well and good. But the majority of jobs I go to, I find out that the waterproofing guys supply the swings, and the window guys are working off it. Some miscellaneous metal guys are working off of it. And some people are actually doing welding off of their platforms. There are certain requirements by OSHA that you need to make sure are included on a suspended scaffold for anybody to weld off of it. Main reason being is if someone's welding off this platform, it's not grounded properly, or it's not insulated properly at the top of their wire ropes where it's required, they could be transmitting current up that wire rope and heating that wire up to the point where it may not have failed, but it's to the point where it's weakening and it's going to fail. And 2 weeks later, after the window guys are done, you guys come out to do your caulk or do some work around them, the wire rope could shear off because it's been damaged beyond repair. So if someone's working on your suspended scaffolds, make sure they're not welding. If they are welding, make sure you go back, give us a call, give any of your supplier of suspended scaffold call, and they will fill you in on what the damage could be and also what the requirements are to make sure you're operating off of a safe suspended scaffold. These basically are the parts and pieces you need. Insulated thimbles to make sure you can't flow arc up and down. There's a ground that goes back from the platform back to the wall surface itself. But this picture right here on the right-hand side is a swing stage that we got back from a customer who was someone was welding off of his swing stage and actually touched the stinger back to the wire rope that wasn't grounded properly and burned it almost all the way through. There's only 2 strands left hanging him in the air. We've had a lot of incidents in the past where people have been killed or hurt badly by actually burning through their wire ropes and having the swing disappear below them and not being tied off properly or hanging too long on the suspended scaffold. So there are rules and regulations for how and why you should do this. And even if you're not welding from the platform, if someone's using your platform, you should really make sure you understand how they're doing it and why they're doing it. And this is just the basket showing the device as it's been damaged itself. And that's all I have, Nicole.
Thank you, Jim.
Hopefully I didn't speak too quickly.
No, it was great. We do have a question from Rob Miller. Rob, do you want to unmute yourself or I can ask the question for you?
There we go. Can you hear me?
Yes.
Hey, Rob.
Hey, how's it going?
Good.
Yeah, so we're structural engineers that do a lot of building restoration. And over the last few years, we have been designing permanent roof anchor systems in preparation for the major facade restoration projects, taller buildings, 15, 18 story, particularly in South Florida. And recently, we had a new owner rep come on, replaced the previous, when we already had contract drawings put together, had roof anchor system designed. And they came in and said, oh, the law doesn't require it. Therefore, we're not going to do it. And so they modified the bid form accordingly. Contractors didn't say anything. And now the work's going to be done, on an 18-story building without a permanent anchor system. And the disturbing thing about it is that in order to meet the the layout dimensional requirements, in order to mitigate the chances of falling laterally 6 feet, and then also having enough structure poking up above the roof to anchor to meet the 5,000 pound ultimate load. It's just seems practically impossible to meet the intent of OSHA without a permanent roof anchor system to supplement whatever you have up there. And I guess we're sort of in our own little bubble as structural engineers, and we're told, nope, we're not doing this. And then we kind of crawl back and scratch our heads and wonder what's going on. So just hoping for some feedback from a contractor's point of view, maybe.
I guess you're preaching to the choir because just about everybody on this call work on rooftops where there are no defined anchor points. And they need to identify, locate, and come up with anchor points that are going to meet the requirements. And there's a lot of different ways we do that, from sometimes taking the wire rope over the building back down to the ground or to the next elevation down and wrapping around a bump out of some sort, or a balcony, or elevator rooms on rooftops, or other kind of structures on rooftops. Every building is really unique in how you do it. I'm not sure what the rooftop looks like on the building you're talking about,
Sure.
but there's usually a way. And they're not always the best way. Sometimes you need to penetrate the roof. Temporary penetrations where you put anchors up there, temporary anchors, which if they're not going to put permanents, they're going to be balking about temporaries, but the contractors are going to be required to tie off to meet OSHA. And we can usually find a way to do it, but there are times when you have to actually penetrate the building or come in a window or come out a doorway below, depending on how occupied the building is.
Yep. Got it.
Yeah, and permanent anchor systems are typically difficult to sell for a project, just because of the complexity and cost of them. But we as an industry think that, you know, every building should have some way to access it, right? Access should be in mind when it's built or when it's restored. That the owner's rep should think about, how do we access this building in the future to do repairs? And really the way to sell anchors and what we've seen here is from a cost perspective. Don't look at the cost of this job. Look at the cost of the 10 jobs you're going to have in the future, that this is going to lower that cost by having an anchor system and make it easier for contractors to work on.
Yeah. Yeah. We
Really is.
certainly make that case.
And Rob, if you want, you can reach out and we can help you at least identify what we feel will be substantial, you know? And then you as an
Yeah.
engineer could say whether it is or not.
Yeah, absolutely. Appreciate it.
Sure.
I don't see any more questions in the queue, but if anyone has a question, please feel free to unmute yourself and ask away.
Hello, it's Rob.
I had a question, for lowering the ropes when somebody's on it. If you do that without the rollers at the edge, you know, how terrible is that?
It depends on the edge. Are you rolling over a nice smooth piece of granite or something like that? Or you run over rough, you know, whatever it might be. You could do it by rolling over a piece of rug or a piece of carpet or a piece of leather, or it doesn't have to be a roller itself. But I would definitely give myself some sort of a way to stop the friction from creating heat or from damaging the rope.
Yeah, we use Kevlar sleeves here, which are great. I've got one actually.
I think you're,
They look just like this. It's a rope protector, but they're made out of Kevlar, so they protect against those edges. So it doesn't necessarily need to be like a big roller. There's all kinds of different options to do that.
I know with the fire department, there's been times we've had to do rescues and you could lay just basically one of your fire coats over the edge. So you're giving yourself something that's going to give you, I mean, you might damage the coat, you might damage the rope, but you're not going to cut the rope and you're going to throw it out at the end of the job anyway, because once you use it for a rescue, you're going to have to get rid of it. So you can use whatever you need to soften that edge.
My thought is more, you know, we can install rope protection as we're doing the drop, et cetera, to do the work on the facade. However, if you're lowering that rope, those protectors that are lower than that, you know, specific roof edge are going to move with the rope.
Right.
So you have some kind of architectural or whatever, you know, eyebrow, et cetera. You know, we still got to get this person down. It doesn't seem like you're going to make your way down to the second story where you have some fancy fascia or whatever. So I guess more that way, something lower than
Yeah,
accessible.
you're going to damage the building for sure. I mean, if you're in a rescue situation, so you have two options. If you rig to lower, a lot of times where you have like EIFS facades and you have these architectural effects, you have rope protectors on there like protect the EIFS from the rope. When you start lowering a victim on those systems, you're definitely going to damage the EIFS or the, you know, whatever facade you have, but that can be repaired. You're going to get the victim down quickly. And when you're using this rope is a lot different than like 5/8 polydeck rope. It doesn't cut super easy. It has a lot of abrasion resistance, so they can run through EIFS and typically be okay.
I got a quick question. It's Mark Howe with BECS, like another engineering company, but someone who was a contractor for 20 plus years. Is there a way SWI can create a paragraph that we can put in our specs that this is mandatory on our projects. As an engineer, just like my buddy Rob, I think it was, we can suggest things until we're blue in the face, but I'd rather have this written in with a paragraph because I'd rather work with contractors who have this set up, because I have 24-year-old kids jumping on the swing stage with you guys, right? Looking at work. Maybe they went up and looked at the roof rigging. Probably they didn't. So our safety director, Scott Vecino, another former contractor, is on the call. We're trying to do a better job of pushing contractors into this. And maybe if we would have a paragraph or something within our specs,
Recommended.
but Jim and I called 20 years ago,
Yeah.
an air rescue descent system, when we were at DuPont, when we both had more hair, we might be able to actually help influence some of these contractors to make it something that at least at BECS we require, you know?
Yeah, I think that every contractor should do this. It's one of the things that we're doing it here at Tatley Grund. All of our swing stages operate on 11mm rope with rescue descent systems. And I think more companies should do it. It's I think intimidating from a cost perspective. It's intimidating from a training perspective, but it does have a lot of positive benefits to the workers and to the companies if something were to ever occur. And also it's just easier to work with. But
Mike, I would say the biggest costing is the rope, probably, honestly, because we do industrial rope access. We know what
I guess
the
the
rope,
one question that hasn't been asked right now pretty much is cost, and it's probably about $3,000 a person for your original setup, including the rope and the lowering device and the parts to do the raising. So I mean, it's a real cost.
Yeah, absolutely.
And to set up, you have 40 guys working for you, that's a real cost. But there are ways that you can actually use a knot as opposed to use a lowering device on every rope, and use the raising device that I showed you to actually take tension off the ropes. You can install the lowering device and then lower and only have one or two per job. So there's ways, if you plan around it and think about it, you can plan your work around expense, but you can limit your expense to the absolute gotta haves instead of having a full system for every person on the job.
Yeah, well, to me, it's kind of like you drive around any of these cities and you think about all the guys that are hanging on swing stages or standing on swing stages that have no way to be rescued. It's
Right.
kind of overwhelming. And I would say this is a mandatory thing, along with mid-motor air exchanges, right? Like
Yeah.
nobody talks about that, and that's not a thing either. So there's just a lot of ways we have a lot of, I think, risk that can be managed a lot better if contractors invested in it, you know, and it's, I think maybe we can help as an engineering community to at least suggest that in our front end documents that it's something that we deem mandatory for job sites. And if we do that, maybe one contractor at a time, they'll invest in it, you know?
Yeah, I mean, it's good thinking. I'm an advocate and supporter of yours, and I think I wish you all the best of luck with that for sure. I think it's a hard challenge to get all the contractors to switch what they're doing right now up for a better system. Now, we introduce these systems to you guys this is like the creme brulee, right? This is the best you can get as far as having a system that's easy to work with, and that if something were to occur, it's a 3-minute rescue. But it's a hard sell. And a lot of contractors that have 50 to 200 workers out there working off swings, it's a lot of money. So I think we just keep working on it.
It looks like Tony Ferrante, you want to take yourself off mute and ask your question?
Yes, ma'am. Is training provided for the rescuers? We can have every contractor can have their safety in a bucket harness, but I've unfortunately seen it occur where someone fell off a roof and their lanyard was too long and it was 20 feet of free fall before it jerked them to a stop. And nobody had any idea what to do. And it was horrible. He was badly injured, but he was conscious. So he was screaming and everybody's running around, unfortunately, like the Keystone Cops, and nobody could figure out how to get this guy up or down because nobody had any training on that. So his harness saved his life, but his life is irrevocably changed beyond that point because he hung there for such a great long period of time.
Tony, training for this, it's a relatively easy device to use. Training is available. We'll provide training. There's a lot of rescue services around each city in the country that provide third-party rescue or training for rope and rope assisted. YouTube, I hate to say it, gives a really great training through like Rocco Rescue and other companies like that. So you can get refresher training online. It's really not difficult. Ultimately, the device acts as a nut, and there's a sweet spot on the handle that as you rotate it to a certain spot, it lowers rope through. And if you let go, it stops. If you go too far, it stops. I wouldn't say it's idiot-proof, but it's really difficult if it's set up properly to not use it properly.
So then the key is to kind of coerce the contractors into buying into these rescue systems.
Yes.
Once the systems are procured and in place, then it's up to them, and the training is relatively easy to get them trained once they actually decide to spend the money for the system.
Right. And the parts and pieces I showed you, they're not the only thing that do this sort of a rescue thing. They're the ones that I use. But there are probably 4 or 5 different lowering devices, like Mike was showing a couple earlier. You can customize your package to your own need or how you want to do it. But I just want to show you in this presentation that it's really simple to set up a system. It's not really simple to afford as many systems as you may need, but having a system on site that you can actually modify and use for lowering or raising just makes it so much easier as an owner or as an engineer or as a manager to know the people that you're working with you or working for you, you're at least offering them the ability to get them to a safe location in a short amount of time. Because some parts of the country are better than others when it comes to rescue. If you're in New York, you're in Philadelphia, Chicago, big cities, they're set up for it. If you're doing work in Allentown, or you're doing work in some other out in the boonies towns, they may not be really well trained to do what they have to do.
Right. Thank
And I'm
you.
not saying that I'm not trying to insult anybody. I'm just saying that keeping that in-house and making sure that you're in control of your own destiny or people's destiny, I think has value.
It's true. Now, the other part of this is that, you know, as a contractor, we're required to have a rescue plan. We're required to have a plan in place if we're working anywhere above 10 feet that tells us how we're going to rescue someone or what the plan is. And that training is required for the workers. But the problem with that plan is that nobody does it. Everyone ignores the rescue part. You throw a stage up on the side of the building and you go to work, and somebody filled out the rescue plan, but no one talks about it. No one knows what you're going to do in case of an emergency if somebody actually falls, because it doesn't happen very often. I think the conversation and what everyone's trying to get out of this is, let's talk about it more. Let's talk about rescue.
Yeah, Mike, the rescue plan I get is usually from a contractor says, I'm gonna call the fire department. That's not.
There you go. But that's not a rescue plan.
That's not
a
a
part
rescue
of
plan.
That doesn't
It's a
meet
part
the
of a
standard.
plan, right?
Yeah, to meet the standard, you actually have to have a rescue plan. You have to have a detailed plan of what you're going to do to get the worker down.
The plan
and
I
you
always
have
hear
to
that
answer prompts.
Yeah. The plan I always hear that I have a problem with is when someone says, I'm going to rig another swing and go get them. It takes 2-3 hours sometimes to rig another swing, if you even have the equipment there. So that's not a part of a plan. But a lot of guys say, oh, I'm just going to rig another swing. I'll keep a basket next to it and I'll rig a basket, but it's not 15 minutes worth of work.
And the problem with that is workers' blood becomes poison to their own body.
Yeah.
And a lot of rescuers don't understand this. Something that is talked about in the industry a lot is when you go get someone off a building, they've been hanging there for 20 minutes, 25 minutes. You can't actually lower them all the way to the ground. You have to float them and wait for EMS to get there, because if you lower them all the way to the ground, you'll kill them. So it's really important to pay attention to those timelines that you got to get. We don't want to see workers go that way.
All right, does anyone have any other questions? Now is the time to ask. All right, well, before I let you guys go, I just wanted to go over a few more reminders. So I will be sending this recording out tomorrow morning via eBlast. And after you guys conclude your guys' stand downs, if you could just send me the sign up sheet, and I will send that out tomorrow as well with the recording. And if you guys have any photos or videos, please share those with headquarters. And if you post them on your guys' social media platforms, please just be sure to tag us and use the hashtag SWRI stand down. And I want to thank Frank and Jim and Mike for all your guys' hard work. And thank you everyone for attending.
Thank you, Nicole. Thank
Thanks,
you,
Cole.
everyone.
Thanks,
Bye,
everybody.
guys.